Hello, everyone, and welcome to the channel. I'm your host, Stefan Burns. Today, I'm joined by a friend of mine who presented something very interesting to me, and it's in regards to some of the biggest explosions that you can imagine in our reality, in space, the universe. These are nova explosions and then even supernova explosions. And outside of just being a sudden brightening of light in the sky, it seems that there are some very real energetic effects that those can cause to our planet depending on the angle of the energy beam. So, my friend is Max Raymond, and he has been doing a lot of deep research into the connection between certain nova explosions, climatic shifts here on Earth, temperature anomalies, and more. Welcome, Max.
Hey, thanks for having me on. I appreciate you taking the time.
Yeah, and one of the most interesting, we're going to get into a whole bunch. One of the most interesting is 1054 because that was a massive supernova explosion. It's visible for
Yeah.
weeks because it was visible in the evening sky and then also in the morning sky.
We had a obscenely bright couple of months, and then for a couple of years afterwards, it was still visible.
Yeah, so I mean, I actually have it here behind me. This is the Crab Nebula, and this exploded in 1054 according to official accounts. And there were some other interesting things that happened right around that time, a Miyake event 1052,
Indeed.
some interesting planetary resonances in 1052 as well. So can you just guide us through an overview of what these supernova and nova explosions are and kind of how you found out about the connection they have potentially to our Earth and the evidence that you've lined up? Because I found it very, very compelling when we met at Cosmic Summit. Is the most compelling thing that I encountered of the different presentations people are giving, and um, that's why we're here on this channel right now talking about it. People are going to love this.
I appreciate you. I appreciate you recognizing and even taking the time then to hear. I'm sure you get bombarded, and I've seen it happen at those events. So um, I suppose the gist of a supernova or these nova explosions are effectively the thermonuclear destruction of star cores and or consolidation and um, integration of binary or trinary star systems. So the supernova is pointing more towards a destructive cataclysmic explosion of a star form that may or may not leave a remnant core in the middle, versus these novas are more like binary star systems accreting mass, and the interactions between their planetary systems as that gravitational pull brings them closer and closer together, and their degrading orbits cause all kinds of madness in the interim. In terms of how I was clued in here, we know it's kind of understood. I had a fascination with CMEs and regular solar phenomenon and how those can have impacts on us through the Carrington event. And when you go to the massive scale of supernova, you then have an actual potential threat to the biosphere and life on Earth, especially if they're proximal to Earth. And so just a general curiosity about space growing up, and deep readings into, that's my spare time is research, honestly, edutainments and other deep dives into different topics that pull me. And the climate shifts being one of them. Dansgaard Erskine cycle, the Younger Dryas was probably a real fascination that brought me in, because we have a consecutive immense drop in temperature and then 1,000 years of effectively winter and a sudden rise out of that winter condition, which is completely anomalous. It's not like anything we experience here in the Holocene. Um, and so it's just a major curiosity to me, and kind of begs the question, okay, what would do that? How could we have that happen? A lot of focus has been put on internal forcing mechanisms, Earth Sun dynamics, but we have a fair record of that dynamic over the Holocene, 10,000 years of solar Earth interactions, orbital changes, and even though there's larger scales of orbital changes over longer time periods, the Younger Dryas was just so anomalous in and out. And so it begs the question, when we're talking supernova and nova, what's the step down from catastrophic annihilation of life on Earth? What is, what if we pull back from the brink of destruction, what do we see? And that kind of reveals itself in the data here.
Yeah, there's, as I understand it, I mean, just kind of when you're researching anything, you see this manifest, but there's different scales and rhythms to everything. And so if you get a small solar flare, and then you get a coronal mass ejection impact, then maybe you get a Carrington event, then maybe super flare, these are all in the range of possibility.
Mm-hmm.
You would think that there's also going to be more significant events, just at probably a reduced frequency of occurrence.
Right.
And when you research into Miyake events, specifically in the papers, they state it very well could be solar or cosmic. We don't know what's producing this spike.
Mm-hmm.
Most likely it's solar, but it seems that most people that have read into this and are, let's say, talking about them or educating on them will 100% go all in on them being solar in nature. But
Right.
that's not necessarily the case. It's just we have a spike in certain radioisotopes that could be from cosmic and or solar forcing. So that is basically still like leaving a lot of room for alternate explanations. And that's just kind of what we see with space weather and that physics community, is that they tend to congregate around one explanation, often to the collective detriment and understanding of what's actually occurring. And then what's really relevant for right now is that we just had two nova and or supernova explosions, two big explosions. We have V462 Lupi and then V572 Velorum. Yeah, and before we get into it, let's just, because this is like very interesting, let's just go straight into showing that climate anomaly on the South Pole and have you just kind of share your thoughts. This will be our intro to kind of what you're talking about. But here I'm sharing climate reanalyzer, and we're looking at the 2-meter temperature anomaly over and around Antarctica right now. So can you tell us about these nova explosions and maybe tie it into what we're seeing here? And then we'll lead in, I think, to the Cat's Eye Nebula.
Sure. So over the last month, I reckon June 12th is when they recognized the arrival of the energies from 462 Lupi, and it had gained, it grew in magnitude to become brighter and brighter over the next couple weeks, and then it was followed up with V572, and both of them are southern hemisphere. And part of the principal notion in my project has been whatever solution explains these climate anomalies should be directionally oriented. It should be relevant when you have things like the medieval warm period that's a northern climate anomaly. And the records within the ice cores, both north and south, show a disparity in the timing of the events and how that energy hits the earth and transfers through. So when we see two southern oriented supernova in conjunction with each other in consecutive order, we're not certain on the proximity yet. There's a certain proximity factor when that has to be scaled in, right? There's an energy scale when you talk about the Miyake events. There's a difference between a 0.5%, a 2% Miyake event, or a 40%, solar flux explanation. You have to be able to point to a mechanism that can do that. So distance is a factor. I think that's why the focus is on our sun, is obviously the proximity of our sun. My dilemma with only focusing on the sun is the duration of the events and the duration that's recorded in the climate records. So in terms of these events, we have an immediate heat wave in the wake of these events through June, global, talking 5-degree anomalies in Washington State, 3-degree anomalies in Western Europe. And when we pull the southern hemisphere, you can see that warm anomaly. There's those two warm spots that are far too early for the season. And
Here and then
yep,
here.
Yep. And
And it's winter there right now.
right. They represent, yeah, they're coming into summer, right? Still. Or well, yeah, right. They're too early for the season. And they represent 25 to 30 degrees Celsius uh anomaly to the warm over average temperatures. So there's obviously a greater delta in temperatures that you're going to see in the in the polar latitudes, both north and south. But when you see an anomaly to the 50 degrees Fahrenheit, 45 degrees Fahrenheit, that's significant. And that's effectively what I've highlighted with the glacial cores. I've mostly focused on the JISP2 ice core because it's a well-studied series of ice cores. So when we're looking at a 10 to 20 degree average temperature swing during the Dansgaard-Oeschger oscillations, during the end of the Younger Dryas, this is on scale to be in line with those. I'm curious to see how far these supernovas are going to be calculated to be from Earth, because that matters.
Yeah, this polarity that's built up in Antarctica with some of these anomalies being very cold and others being very hot just basically indicates that there's been some influx of volatility as like a derivative of the main forcing factor, you could say. So if there was if these novas or supernovas did have a pretty condensed beam that hit us, then that could be the first order, and then the second order stuff would be all of a sudden we start getting these climate shifts. But we do have these like cosmic ray detectors all over. So I don't, but that's the thing. If there's southern hemisphere and it's funneled to the poles, I don't know about our cosmic ray flux detectors in the southern hemisphere. I haven't looked, but at least we know that these nova explosions occurred. We have the light curve for V462 Lupi. We see that it basically started on the 12th of June, spiked up many different magnitudes. Each one's like a 2.54 times jump, something like that. So, it starts to scale up pretty quick, reaching peak around the 21st of June, but still elevated over normal. So that would be more indicative, I would say, probably of a supernova there because it's staying elevated.
A 3 to 4 million times brightening, right?
Yeah. And then here's 572 Velorum spiked on the 27th and 8th of June, and it has settled off, but basically spiking up from not visible at all, if I'm remembering correct.
Yeah.
So it is still elevated overall. And yeah, whether it's a nova or supernova will be determined, I guess, in short order. But the fact that we had two back to back in the southern hemisphere, now we're seeing these crazy anomalies and also climate instability in the north, on top of the fact that we were having like the SMOC salinity reversal happening. Definitely like an unexpected sucker punch maybe to the earth.
When you say SMOC, which overturning is that? At southern meridional?
Yeah, it's just like the deep water circulation, but it was pretty low saline for decades, and then in 2016, this paper just came out, but in 2016 they showed a pretty sudden shift in the salinity of the surface water around Antarctica. So now it's warmer and it's more saline. It's like a 1 degree Celsius difference between the two, but for those sort of systems, that is significant. So people are still digesting what that means. Some people are going too far and saying everything's reversed. It's like salinity has changed. There's probably a natural oscillation anyways between more saline, less saline across some time span, and then there's variations upon that. That's the thing once you get into this. There's so many of these nuances and fluctuations that you can't just be like, this is 100% the thing, but it all adds into a comprehensive picture.
There's a lot of energy transfer mechanisms at play. We have our inputs, we have our transfers, the dissipation of energy, and they all factor in.
Yeah, so before we get to 1054 in the Crab Nebula, and I don't know what you call it before it was a nebula, just maybe the crab, but if you could show us some of this ice core data and the temperature spikes and how you've correlated that really nicely with the Cat's Eye Nebula, because it's really fascinating. This is when you pulled up this page, I was like, whoa, that is cool.
That's really what, the Younger Dryas was the focus, but then when you have the syncopated time series of the Cat's Eye event, it really blows the concept out of the water, to use a colloquialism. So here's some images of this Cat's Eye Nebula NGC 6543, also designated Caldwell 6. On the one side, we have this gorgeous colorized image that shows the different emission spectra. You can see the polarized jets coming from the north and south pole of the current orientation of the star. And we see this series of ring pulses, right? We've calculated around 10 or 11 of these. And each one of those you can think of as a thermonuclear explosion or an energetic release from the star. And these are calculable. You can kind of read the geometry and see that, let's say, some of them don't have the same duration between. And then at some point they stop. And then finally we have this inner nebula of a massive explosion. And over here is just the X-ray emission spectra. So these will be those same two jets, where your gamma and X-ray radiation is the synchrotron radiation is shooting out of the poles of that star, because that's simultaneously a bit of a weak point in the magnetic field and works as an accelerator, in terms of shooting your energized particulate and plasma out of the magnetic field lines, accelerating them through the field lines and creating that beam form. And interstellar jets have been recognized as being hundreds of light years across, depending on their formation energies of the central object that's emitting them. So whether it's a Wolf-Rayet, core that's kind of symmetrically off-gassing with its regular magnetic emissions, or something like this that's a pulsar, or a magnetar, which goes even stronger. This is a zoomed out view of the nebula. We can see that interior nebula with the ring forms, and beyond that, this is some 60 to 100 light years across, where that inner nebula is a couple light years. So this is a huge form that has been expanding for calculated 50 to 90,000 years. So in the heart of the last ice age. Just gorgeous, because it shows the different scales of the events. We have, 1,000 years ago this happened, and then 20,000 years ago, 25, 30, 40,000 years ago is the time scale that's represented in this signature here. And then this is a NASA work page that kind of runs through some basic maths. I consider this 45,000 year spacing timing between the rings to be 2 times too long, because there's a hiatus of ring forms towards the center. So it should only be, say, 40. What they calculate is a start at 46,000 years ago for the first rings, and that should be cut in half for those 45,000 year rings, because it stopped doing those ring pulses at some point. And so the nitty gritty, it's located about 3,300 light years from Earth, which puts it within the range of having an effect on Earth here. And there's also the radial velocity suggests that the nebula and our solar system are moving away from each other. Calculated to have started at 46,000 years ago, but there's other calculations that it popped at 4.5 thousand and also 1,000 years ago, which is in the heart of that medieval warm period. A half a light year is actually the diameter of the central nebula, and 3 light years for the gaseous shell.
Yeah, and just for the viewers, we have 3 Miyake events that have been recorded. One at the beginning of the medieval warm period, effectively. That's like 994 or 80, somewhere in that zone. And then 1052 and 1279, I believe, AD. So what caused those Miyake events is a good question.
So one of the important recognitions is the direction from which these energies would be approaching our solar system. And it's centered in the northern constellation of Draco. So that means that any of the EME energy, the electromagnetic energy and radiant beams would be coming from the north. So northern constellation of Draco is where it's coming from. This orients us towards where we should be looking. We have the constellation of Draco here. We have Ursa Minor, the Big Dipper here. And it's tucked away over here within the body of the dragon. Another reference point for us. So this constellation of Draco circles the northern hemisphere. It dips below the horizon, but it's definitely a northern circumpolar constellation. And this here highlights the series of events. So if we have that ring, the Cat's Eye Nebula, energies from the nebula calculated to arrive at Earth at 46,000 years ago, we have a vertical 15-degree temperature spike, which is highly anomalous. This cannot be accounted for with internal forcing mechanisms or Milankovitch cycles. Milankovitch really does fail at explaining these because it's such a low percentage of change in total solar radiation radiance. So what I see when I look at this is an input of energy followed by a return to homeostasis within standard Earth orbital energy cycles. And then we have a series of 10 consecutive ejections that are relatively evenly spaced, and they all have that same scale of input. So every time that star goes boom, 4,500 years, 2,000 years, 2 or 3,000 years, we see that energy input to Earth followed by a return to homeostasis. If this was natural Earth cycles, we would see a regressed average of swings. When I look at 20,000 years, this range here, this is exactly what we see in Milankovitch flux. And I've kind of highlighted that in other slides here, but this is the fluctuations that we would expect to see from internal mechanisms, smaller scale mechanisms that affect Earth change. And this overall arc here very directly mirrors Milankovitch swing. And then it goes to a minimum, and then it comes back up to a Milankovitch maximum coming into the Holocene, but then right around here, the Milankovitch drops off and we stay warm. So this really highlights the syncopation of the Cat's Eye Nebula event starting at 46,000 years, 10 consecutive events. And then I thought this might be part of it when I was putting these together. I have since recognized this to be the more likely the Cygnus Loop supernova, which is a very proximal, pretty big event. And then again at 4,500 years, they've calculated the Cat's Eye to have gone, and of course the medieval warm period as well. So in here, I've also highlighted the Le Champ excursion because that happened over here, and that was a massive excursion of the Earth's geomagnetic field in the poles. So I recognize that, with plasma energies and energized particulates coming in, and even just an electromagnetic beam forming mechanism, a laser beam turned on us, that can affect the heliopause, that can affect the Earth's magnetic field, and effectively add a pressure, create a pressure up against our fields. There's two ways to affect a magnetic field. Externally with the input of electromagnetic energy, electric fields, or internally by changing the shape of the magnet. Shattering a magnet will change its magnetic field, or, and when you're talking about the Earth, you're talking about changing the dynamo of the core and the core mantle interactions in order to cause a massive change. It seems much more likely that an external electromagnetic field was applied that would force that shift until it goes away, or until it returns back to homeostasis.
Yeah, Le Champ's interesting because we don't know exactly what happened. We do have our virtual dipole positions, everything.
Right.
And there's some really high resolution data right from like basically the swamp due to this petrified tree that they found in New Zealand. And I read that
Right.
paper, and what they say is like, well, it seems based on the radioisotope data, it seems that there was a sequence of grand solar minimums and that the field strength was low. But effectively, because of the radionucleotides and these isotopes going up, they saw that cosmic flux was a lot higher. And so they pinned it on, well, we see that the dipole moved and the remnant intensity and all this stuff is different. But they also speculated that because we're at grand solar minimum, that would let more of this cosmic stuff in. So if the field strength is reduced, when you have this sort of plasma, let's say, coming in, and now all of a sudden hitting field lines in developed electric circuits like that exists all throughout the solar system, that increased flow would actually generate stronger magnetic fields. But if there isn't much of a field to begin with, then that energy will just basically go down to the surface more so and increase the cosmic flux closer to the surface, like a ground level enhancement event, but on a much larger scale. So that, I mean, how that then starts to interact with the Earth. I mean, for example, with Mercury, we see that some of these electric currents in the solar wind, um, they can't couple with the Mercury. They can't form a circuit closure with an ionosphere like we have because Mercury doesn't have an ionosphere. So they suspect that these circuits form, these Birkeland currents that come out and then hit Mercury actually couple down at the mantle or even the core of Mercury. Whereas Venus is a very strong ionosphere and a huge atmosphere and a very developed filamentary and electric current network through its ionosphere. So as it relates to Venus, it couples at the ionosphere and that circuit can close. And as it relates to Earth, it also hits our ionosphere, but it also can go out even further to like the magnetopause and it can do some circuit closures there. But if we do have these grand solar minimums at that time, and we have this huge amount of cosmic flux coming in, our ionosphere from the reduced solar input would be quite a bit weaker. And so it's possible that these electric currents would go down deeper to the planet. Perhaps even some of the circuit closure would occur underneath the crust and down maybe towards the mantle, or there's remnant magnetic structures at the core, at the crust mantle boundary. Maybe they form circuit closures there. So there's tons of unknowns. What I'm saying is basically there's tons of unknowns. We don't have a definitive answer on this. Maybe some sort of impulse could trigger a state change in the magnetic field and alter the geodynamo, georeactor processes occurring deeper in the planet. It's just a big unknown, but
But you should see if it was this, you would see a consistent signature of that magnetic shift along with these climate fluxes that are in the ice cores anyway, which is mostly most of this data is centered around the oxygen 18 cosmogenic isotopes
mhm.
and their flux.
Yeah, so it's a complex system. I'm more inclined to think that Earth's magnetic field is a little bit more under her control than some of these
Right.
outside influences. But obviously, it's like this balancing act. I think what the sun's doing and what the cosmos is doing definitely matters, and there seems to be a bit of intelligence to it. But without going like too much deeper into that, it's definitely it's a three-part problem with like what's Earth doing geophysically and what's this magnetic field and all those systems.
Yep.
What's the sun doing? What's the cosmos doing? Because they all interact together. And that's what makes it difficult for some people because, well, A, we don't even have the answers, but a lot of people can only focus on just the Earth or the sun or just the Earth and the cosmos or just the cosmos and the sun. But to put all three, now it's really hard to decipher what a radioisotope spike means. Because is it from the sun? Is it from the cosmos? Maybe the cosmic influence caused the sun to have a super flare,
Right.
right?
Are these events feeding the sun, which is
Yeah,
completely within the realm of possibilities? And
that's
it would have to be. It would have to be feeding the sun just as much as it's feeding the earth.
That's what I'm inclined to think. That's what my intuition is poking and telling me is that the sun, maybe it's middle aged, maybe not, but I think stars, they're given a certain allotment at the beginning with uh, their dust cloud and the
Yeah,
accretionary phase.
you have.
But I don't think that excludes the potential for a star to undergo evolution if it gets hit with a bunch of plasma from another star nearby saying, "Hey, I got you. Here's your hookup." It's the
Yeah,
same thing in life. You can sometimes uh there's tons of people that have, made it in life in terms of money. They were dirt poor and then all of a sudden they're billionaires. I think the same thing probably happens in the cosmos in a variety of ways. But yeah, these spikes in the temperature data and the fact that there's basically the same number as those rings in the Cat's Eye Nebula, and it's not like you've got it in it exactly precise. There's so much. There's definitely a lot of wiggle room and ambiguity in this, but overall, it matches up pretty nicely.
that
So
36,000 year initiation is really a bit of a linchpin. Um, but yeah, and then calculating, you can see the changes in geometry and the spacing in the rings. And again, there's some uh, um, subjectivity to it, but in how you're reading those rings. But you can see the changes in temporal spacing. Um, when and then if you pull to the Holocene data, we're talking about a couple of degrees of change. We're talking about 3 degrees versus the Dansgaard-Oeschger 10, 15 degree swings in temperature. It's drastic. If our climate change is dramatic at half a degree or 3 degrees, what does 15 degrees mean? As a little preview on the scope of the project. And one of the two real linchpins, the Helix Nebula, um, at the end of the Younger Dryas, paired with the Vela supernova, and the Cat's Eye, are really just perfect timing. It's perfect timing, and I know that's not the only thing to look at, but if we have an astronomic record that is perfectly timed with a climatic record that is also perfectly timed with, let's say, anthropologic records, that's a trifecta, and that's a triangulation of data at that point. So, if it happens once, it's curious. If it happens twice, we're starting to see a trend. But when you have 10 to 15, consistent events, it's a pattern.
yeah, and what's another nice lineup in time, which I haven't seen any research connecting the two, but there have been papers and research done on them independently, is the supernova 1054, which
Yeah.
created the Crab Nebula, and then the Miyake event of 1052,
Mm-hmm.
and also some very interesting planetary resonances that occurred in 1052, which, I mean, maybe it's just my imagination getting a little wild, but if you think of like the gravitational field dynamics of the solar system, then the sun could perhaps position things in such a way to catch a plasma wave coming in, and because it wants to get at, there's always loss in the system. So it's like, hey, I need to eat every now and then. It's
Yep.
just going to want to catch it what it can, and that would mean sending the planets in such a way that you have planets that are further out in that alignment. They're slower. They can pull it in, but the inner planets create like a conveyor belt.
So this is the latest and greatest imagery from the James Webb miracle that we have up in the heavens right now. And we've had a lot of imagery come from the Crab Nebula, that 1054 supernova remnant. But this is pretty, really pretty, I think. It just kind of shows the different uh, energetic constituents in a singular image. So where we see the red and the oranges is doubly ionized sulfur. The blue is going to be irons, and dust, which is going to be your silicates and other minerals, is in white and yellow and green. And then here in the center, this swirling bit is going to be a central pulsar and its emissions. Uh, Classically, we've seen something more like this image. I'm not really sure. I guess this is where the crab idea comes from. This is, I guess, Lord Ross's initial drawing of what he thought it looked like in old telescopes. Yeah. So obviously we have a lot better data through the digital sensors now. And to me, these look a lot like plasma filaments. So, you know, it hasn't changed that much over time, but uh, plasma discharge is over here right now. We're in a storm. Um, so yeah, the old view of it. This kind of orients us to where it is. If this is the constellation of Taurus and the horns of the bull, it's right there nested within the horns. And, battling with Orion.
Directly on the ecliptic plane, like
Yes.
smack dab on the ecliptic plane, which means that if you were to have like a sequence of planets do something interesting at that point, it would be perfectly positioned perhaps to like catch something.
They're all catching it. Yep.
Gravity, electromagnetically, probably more so gravity, but pulling things in. It's a really interesting idea. We'll get to that.
Yep. This just kind of shows a little cell diagram of the structure, showing that internal pulsar with its emission jets. And, they're constantly morphing the structure of the nebula over time. It's going to be pulling stuff back in, ejecting back out. And that's where you'll see different pulses, different explosion events, solar system scale thermonuclear explosions. The X-ray emissions coming from that super fast spinning central star. And then, the infrared and radio signals bouncing off of all of the gunk that's been emitted, all of the particulate matter that was a solar system, that was a planetary system.
And just for your viewing pleasure, folks, here we have the Chandra X-ray image of the Crab Nebula. And there's a lot of talk out there by a variety of people of these birdmen. You have this whole birdman kind of cult on Easter Island, Rapa Nui, and we see this also carved around the U.S. petroglyphs and stuff. Well, you literally see a bird here. Like, at least I do. I see the birdman very clearly with this X-ray image. So it's not like, as far as we know, ancient people could see this with their eyes, but there seems to be something to this archetype of the birdman in our cosmos and our reality framework.
Yep. That dipolar emission. And yep. This crab supernova is recorded in petroglyphs and pictographs all over the Southwest. This paper from E.C. Krupp does a really great job of delineating through the collection of pictographs that are potential representations of this event. This one really pulls apart which ones are and which ones are not. This is an iconic picture. This is my taking of the same angle that 1,000 other people have taken the picture, but it shows this starburst effectively within a few degrees of that crescent moon shape, which is what astronomers have calculated would have been the orientation of the moon in the supernova event in mid-July or early July, I think it was.
And I said actually a partial eclipse. Like, a lot of people think that they recorded a partial eclipse that happened at the same time.
I hadn't read into that I hadn't seen that come up in my digging, but I
did.
Yep. I mean, look, yep. Seems like the right time. So
it's one of the two. It's either crescent moon in that petroglyph, or it's denoting a partial solar eclipse. And that's what a lot of people were a lot of researchers were thinking, because I think that's recorded also in the Chinese account.
Right.
I think they also recorded the eclipse, which would give us a precise marker in terms of the planetary resonances.
And the Chinese gave us a really detailed record of this because their culture has survived through, whereas the Chacoan culture abandoned this area and only left sort of these abstract designs that we don't have a written record from them. We have that from the Chinese astronomers, and they, when you consider the eclipse and everything, this was a 2-month, daytime light at night it was almost daylight bright at night for a couple months, and then for 2 years you could still see it through the night. So it's you have a good time span to observe this and to record, whether it's the first coming of the star, or hey, there's this bright new visitor star next to the eclipse, next to whatever it may be. And that's excellent details, because, well, I mean, we see them now. We see supernovas, and we can calculate their duration now, and record them. So this just confirms the archaeo record of them. I've questioned whether these other circles that are behind this painting are part of the star orientation, or if these are just wasp nests that have been cut down. I really can't tell. They look a lot like they've been carved in or painted on. I just don't know. Great place. If you haven't been to Chaco Canyon yet, it's a 7-mile hike to get in and out to see this, but there's a lot of really amazing structures and artwork along the way through that whole canyon. Kim Kletso, this is that Chaco Canyon. Some of the structures that are left there are 3 and 4 stories tall, with some really good stonework. You can look at the different series of stonework based on the building cycles out there. There's a massive culture that was living there that would have been astronomically knowledgeable, spiritually knowledgeable, that felt it was necessary to record this and pass the information on. So
And it occurred basically at the beginning of the medieval warm period, which had heterogeneous warming across the globe, and the polar regions in the northern hemisphere. So it's like Greenland, Iceland, Newfoundland. Those areas were warmer then than they are now.
right.
Which is why it was possible for example, the Vikings to settle Greenland. So it was anomalously warm, and then that came to an end. But that warming was not uniform across the globe. And so you have this event happening, and seems that
Northern summertime.
yeah, if this energy from this supernova, well, the energy from the supernova definitely hit us regardless, because we saw the increase in light. The question is, like, how much energy was there? What's the mechanism? There's some data connecting cosmic ray flux to like cloud formation in the sky, but there's a lot of debate on this. But you don't necessarily need the biggest thing ever to trigger a shift. Sometimes it's just, does it hit a particular system, and then there's the butterfly effect.
Yep. In the climatic modeling, computer modeling, the only way that they're able to develop these Dansgaard-Oeschger events and these rapid, drastic flux events is by adding stochastic noise, which is fine. You can make the computer program work and show or echo a similar occurrence, but then you have to explain what that stochastic noise is. Like, adding noise to a system is just adding noise. But when you translate that to the real world climate and cosmic, domain, you have to explain what that noise source was. So, and that's just kind of what this is aiming at. It's a little bit of noise here at the right time in the right moment makes a big difference.
So on that image from Chaco Canyon, are we actually looking, the left one, are we actually looking up at that?
Yeah, this is 25 feet off the
ceiling.
ground. This is 25 feet off the ground, looking at the underside of the rock. You can kind of read the geology here, and there's probably a rock ledge that separated that you could have stood on up here. I think it's just as likely that there was a structure like the stone structures that they built along the cliff sides all over the canyon, right up against the cliffs, integrated. The back wall of your house is the cliff wall. So I think they could have just as easily been standing on a roof line in their observatory, basically, watching this happen and painting it.
They were clever.
Yeah. One thing that I've recognized is kind of missing, kind of maybe back to the Birdman, is this image is just sort of this way on the wall. And I never see it integrated to the conversation about this. If this is our supernova pictograph right here, this other carving is down on the wall down this way more.
Hmm.
And you can see, there's other pictographs drawn in below. We have the Chaco this is kind of an iconic time spiral,
Hmm.
a bit of a time accounting mechanism that they would have used. Same thing as the hash blocks. They can be used as time signature. But you can see where there was at some point another rock ledge here that has fallen away because the patina from underneath it.
Actually, go back one slide, please. Go back to that main slide you're just on, because it showed three things. So,
Yep. Oh,
yeah. So what we see,
let me get back to
we see two stars basically. No, not that one. The one on the ledge. The main petroglyph. Yeah. So we see something that looks like a crescent moon, and then we see two stars next to it. Is that right?
This is a handprint. This is
Oh,
the
it's a handprint.
Yep. This is we were here.
So, okay, that would make sense, and that is probably the eclipse, because we know, according to the accounts, that it was right around. It basically happened. It was like a supernova Cassini, effectively, where the sun was in alignment with the nebula when it exploded. Because again, it crossed that boundary of being visible morning to night. I can't remember the order, but something like that.
If this
Which
is crescent, your lit side, your lit crescent, then the sun would be over in this orientation.
Yeah. So, I mean, it depends on when they recorded it, but I would think they would put the reference frame of the sun in there. And if there was an eclipse, if I remember the accounting correctly, there was an eclipse. And then after that eclipse ended, all of a sudden, this new star appeared in the sky.
Right.
Like, think of that, like just that as an omen. Like, here you get this eclipse. And that's already seen as a super powerful event. And then the eclipse ends, and there's literally a new daytime visible star in the sky, brighter than Venus.
Yep.
Right? The second brightest thing in the sky, or the third brightest thing, I guess, behind the moon. And then, of course, the sun is the brightest. But that's pretty insane. And that would mean that it happened during a solar eclipse, and it is a supernova Cassini, when the sun and the supernova were conjunct, because it occurred. The Crab Nebula is right on the ecliptic plane, so you could literally have that, and so that light flux hitting the sun is insane.
Yep. If we reference back to the supernovas that we've just experienced in the last month, we're talking about 1%. I think it was 1% of the magnitude of Vela, which is significantly less than even Venus. So yeah, it's super bright. This was super bright. And at I think they say around 6,500 light years, 6,500 light years. It's kind of at the distal end of what I think would have an effect here on Earth, a significant effect. And that's then I got a couple slides coming up that show the climate record and how that plays into this timing as well. I think it's really curious that, when we speak to social change as well, and the us reflecting the greater, what's happening on the greater scale, there's definitely a lot of weird things that happened in this time frame. So, we see this here recorded in Chaco Canyon. We have a Chinese record of it. I haven't dug into Africa. I believe there's also Australian records. But yep. But there's no European record. There's like a couple of maybe a medieval wood painting, but there's no real record of this event coming from Europe. But what also happened in Europe in 1050 is the Great Schism between the Roman Catholic and Eastern Orthodox churches, where the Eastern Orthodox Church said, "Hey, you guys are messing up the tradition. You're not protecting the tradition in the way that you should." And since then, there's been that schism between the cultures, the essences and energies separation, where, one group kept the old way and one group carried on with the new. So I just think that that's pretty iconic that those were also timed perfectly.
Yeah, perfect example of mundane astrology, and also both of those. I think both these things are still being felt to this day. Obviously, the Great Schism is still in effect,
Mm.
but this supernova explosion, I would be surprised if it's still there's a tail to those energetic effects that we're still going through right now. Because if you look at some Miyake data, we see the three Miyake events, we see the medieval warm period, and then we start to see this grand solar maximum click in, the most recent one, the modern maximum. And if there is this plasma interchange, then that could explain how, a few hundred years later, this energy is integrated, and then you start to get these really big increases in solar activity, sunspot cycles, and a really strong solar dynamo, because that energy in plasma, material, whatever, has eventually gone down deep enough into the solar dynamo. So it's just an idea. It almost does look like you have the input and then you have the output in this data that I'm showing on screen right now.
It's one thing to just have a painting on a rock, the anthropologue. And that lines up with the astrologue, the astronomy of it. But within about 150 years or 100 years, Chaco Canyon had its first phase of abandonment. And it's generally attributed to the climatic change. And then finally around 1300 AD, there was another sort of mass exodus. But in the immediacy of the 1054 event, this paper asks, could the carbon-14 production in 1055 be affected by this supernova event? In this paper's abstract, annually resolved radiocarbon-14 measurements on tree rings led to the discovery of abrupt variations in carbon-14 attributed to large solar flares. We present new results of annual and subannual C14 flux in tree rings from middle latitude sequoia in California and high latitude pine in Finland, analyzed for the period 1030 to 1080 to trace the possible impact of the Crab supernova explosion, which occurred during an Oort minimum of solar activity. The results do indicate an increase of C14 at 1054, 1055, which they estimate is higher in magnitude than the cyclical variability that we were experiencing at a 2 sigma significance. It confirms through the dendrochronology that this is our Miyake event, this is our supernova in time with each other, which here's some of that GISP2 ice core data, and right around 1,000, we can see this. If you look at this, it would be more, 1050 would be just after 1,000 years here, and a lot of people have linked this to a climate cooling, which of course, if we have cosmogenic particles being generated in the atmosphere, that could be clouding and shrouding of the sun. But I think that energetic input is a little bit more valuable towards the warm, and then their fallout may be that things cool off. This is a little bit better granularity on the time scale, and it shows that this 990 that 1050 is really right in line with this, quarter degree, half degree spike that we see here. And this is more specifically a drought index for Chaco Canyon, which if we pull to 1,000 years, 1050 is right there in between the two. And we see a massive spike in precipitation right at that 1050 mark. If this is our regressed mean average line and our average scale, something happened that's on the order of magnitude that's twice as much precipitation over a couple years. So there's another supernova event around 1080, which is right here in this time frame. So we see an increased precipitation in the record that is perfectly timed with this 1050 event. This UC San Diego paper from Wolfgang Berger shows reconstructed social stress level in Chaco Canyon resulting from adding building activity and inferred food shortage. The index scales are arbitrary. The inferred food supply is a function of the drought narrative. So obviously drought conditions means less food, and the building activity index is the gray line. And what we see right here at 1050 is a massive spike in labor output and building output in Chaco Canyon, because we have more water, we have more food, we can build more structures, and then that tapers off. And then we see it again at the 1080. We have another supernova event, and we see accelerated hydrological cycle, and we see accelerated human building cycle. And this red line is just the calculation of drought plus labor, and they just kind of gave an average curve of it there as well. So this was a really interesting paper to kind of poke through as well. You know, it brings the human aspect into what the climate was doing. And with even more granularity, Scope Synthesizing Knowledge of Past Environments website has a Chaco Canyon record, and we can see our orange line is our average precipitation values. If 1050 is this gray line, we can see immediately after 1050 we have a it's not quite a doubling, but I don't know, 40% over the average in this precipitation event, that then carries through to, to 1080. We see the same thing here. So accelerated precipitation temporally tied with the supernova event of 1054. And what that means for right now, as we were talking about V462 going nova, this kind of orients us to it. We can see this little star. What we see is a 4.4 million times brightness increase as compared to the plus 22.3 of the star's original or regular output. So to me, 4.4 million times doesn't just signify an explosion necessarily, but that, amplified stimulation of radiation, the laser forming mechanism. So you have this chaotic disintegration of all the planets and the star materials cast out into space, and then you have an explosion inside of that works as the lens on a lighthouse, that you can have a little bulb in there, but it can broadcast for miles because that the light is organized in such a manner. That's lensing versus laser amplification. But that laser amplification is really the process that can deliver the energy across distance without the degradation of traveling through space, the waveform propagation, inverse square law, the, passing by magnetic fields, and just like a flashlight diffuses over a certain amount of space, that laser beam can go for a mile. That 4 million times is a massive spike. There has to be some mechanism by which that light energy and heat energy can get to Earth and the sun, if it's going to have an actual effect. Like this is just some data about the V572, which is calling only 55,000 times increase in magnitude. So it's a little bit brighter regularly, but it also got to be a brighter peak magnitude at 4.8. So, and of course there are gamma ray emissions that have been read from these events. In modernity, that's this month. This, as far as I can tell, this is the unfolding of this project in real time. We now have the data collection mechanisms through our sensors and telescopes to confirm or deny. So I'm excited to see what comes of these two events.
Yeah, and the gamma ray angle is interesting because the sun really doesn't release too many gamma rays, only during like really significant solar flares. And so that's probably the brightest gamma ray object in the sky, or at least one of them temporarily as it's going off. And that's the most vibrational wavelength of light.
This is just a photo that Bryn took out of an airplane facing south. We could see the horizon line here. This is lights outside of Las Vegas. And we have star and star and star, and this really bright object in the middle here, which we think is one of those nova events, because this is the same time that 572 was at peak magnitude. So just a curiosity. And this is, what does it mean for us now? So Copernicus says that this June was the third warmest June globally, with heat waves in Europe. And we can see over here we have a 2.8, roughly a 3-degree above average temperature anomaly in June. And this is the western side of Europe. so the UK and Spain and France, and this is where all that southern tropical energy, that if we have a southern input of energy from those nova, that's all going to be dragged up through the Gulf Stream and deposited on the west coast of Europe here, through the different air circulation patterns. Here we have Washington State. Washington State Climate Office has the full month of June and their temperature anomaly, and we have 5 degrees above average temperatures in these parts of Washington. We have the Cascades here. This would be the rain shadow of the Cascades, and it's hot. It's usually pretty cool and pretty wet up there, but they've been having some real heat waves. This touches on the Antarctic vortex that we were talking about, and it shows initial signs of disruption with the early waves around this polar vortex, and then intensification and broadening are forecast for this month, July. And what we have there is, again, that 25 to 30 degrees Celsius anomaly above average forecast. While the direct impacts of this SSW are confined to the southern hemisphere, analogies with similar northern hemisphere events suggest potential for broader atmospheric teleconnections. So that's pointing to the transmission of that energy from south to north. And I just kind of wanted to highlight some precipitation values, because I do believe that this is the unfolding of this energy input in real time. This is a 30-year annual average of precipitation in the United States, bringing it back home. And I want to focus right here on Central Texas, because obviously the tragedy that's just occurred there, I think it's important in recognition of these events, where they normally have, let's say, 20 to 36 inches, so 2 to 3 feet in that Central Texas region for annual average. In July, they typically will have a 1 inch to 3 inch average in a given month of July. This is what we have for the first week of July in southern Texas. They are getting a dry year's worth of rain just in the first week of July. Same thing over here in North Carolina, where we've got a significant spike in rainfall and through some of these plain states as well. And just highlighting that further, this is a precipitation anomaly. So the percent above normal for this area, and they're at 400% above normal. And that applies over here in my neck of the woods in North Carolina as well. So it's accelerated hydrological cycle. And I know this is kind of regional and certainly weather-based. However, it's indicative of an increased amount of atmospheric water vapor, as well as a way to release that. And if there's cosmogenic particles that water can adhere to and rain out, then we see crazy things like this.
So, yeah. More sudden, more frequent, more severe, faster, volatile weather events. That seems to be the direction that we're going. And interesting about that location is that's where we have both of the eclipse paths intersect, is right at that zone. And so if this supernova did occur with an eclipse, and that shows it has some connection to eclipse energies, and then we get this double eclipse over the United States, a lot of people talking about that, the significance of that. And now we're seeing this massive deluge of water while we have Jupiter back in the same position as it was in 1776 with the sign of the Declaration. We have Uranus in the same part of the sky, Neptune in the same part of the sky as the Civil War, Pluto in the same part of the sky as the American Revolution.
With civil upheaval everywhere these days.
Yeah, so it's a lot to hold on to in the head, but definitely very, very interesting. I want to thank you for presenting this. We'll talk about this more. There's a lot more research to do, but if you'd like to follow Max, then you can go to his YouTube channel, which is Don't Trust My Camera, but Don't Entrust Share the T. So DONTRUSTMYCAMERA. That's his channel handle. It's linked in the video description. Thank you, Max, for jumping on and showing us some of your original research, and hope to learn a lot more about this connection with your help.
Same. Thanks again for taking the time. Don't trust my camera. Figure it out. See for yourself,
Yep. Do your own research, folks. Thanks so much. Have a great day, and we'll see you soon.
Take care.